It's configurable through IP networks. It supports both LAN-to-LAN, LAN-to-WAN, virtual private networking over, whether that be a dial-up connection, whether it's a high bandwidth connection, whatever. It's going to support external users to get into it, and also supports network addressing translation. We have built-in support for RIP version 2 and OSPF. Go ahead. Also supports IP multicast, demand dial routing, DHCP relay agent, and packet filtering. The installed options that we used in our implementation was RIP version 2, network address translation, and VPN packet filtering, as well as DHCP relay. For RIP version 2, one of the reasons that we used it is because we have a dynamic multipath network, all right? And this is not a huge network. I know the 2,200 users sounds like, oh, geez, that's huge. It really isn't that big. We selected RIP because it has the ability to automatically update with its neighbors so that the routing tables stay constantly updated with each other. It's not going to create too much of a headache for the network because the network isn't so big. Once the network gets built to a certain point, then we're going to have to go to an OSPF situation, but for now, RIP was the version of choice. It offers us password security between the routers themselves, whether that be for a neighbor, where there's some issues there with the neighbors, but we have the router here and the router here. They have password protection so that they only talk to each other. So if somebody inserts a router in the middle, they don't have a password, they're not going to be able to update routing tables and hijack packets, for lack of a better word. We selected multicast broadcast with RIP2, which basically means that all the routers get to update each other and everybody gets to talk and know what everybody else's routing tables are, if they have the password. We also used network address translation, or NAT. This provides us an external connectivity without compromising the internal network. This is packets that are destined for the internet, basically are allowed to pass through the internet, but the IP packet header is changed so that they don't have the internal IP address of the originating computer that sent that packet. RRAS deals with that by changing that header, sending it out on the public IP network. Public IP network sends it back. It in turn returns it to where it was supposed to go to begin with. Go back. Backwards. This provides us with external connectivity without compromising any of the information on the internal network, which is important. And it also provides some other functions there. We'll probably get a question about that, folks. Go ahead. Onion Buster's coming, guys. I know it. We got VPN packet filtering. This provides security for incoming and outgoing packets. We instituted IPsec. What is TC? No.
L2TP.
Yeah, L2TP, thank you. Over IPsec, with IPsec for the security that provides us for both our ingoing and outgoing packets. Go ahead. Another one? Nope, go back. Thought there was more there. That's all here. Let's see. By defining what we could do with the VPN network, we control what happens with the group policies. When you have a dial-in connection, it comes in, it's going to initially hit the router, whether it comes from a dial-up, whether it comes from a VPN, whether it comes from another router somewhere else in the network. It's going to hit the router, and that router is going to say, do you meet this criteria? Because if you don't meet this criteria, then I'm not going to even check with the domain controller to find out whether or not I should pass the information on. All right, you meet the criteria, it goes to the domain controller. The domain controller says, yes, this is an authenticated user. And then at that point in time, it's going to grant some access to that user. We can control what portions of the network that user has access to. We can control what areas, what services, all based upon what we have set up in the RS server. So it becomes a very flexible solution for the network. The other thing that we did was we put DHCP relay agents. These will be used wherever possible, wherever we have if we have a server there that's got a little bit extra capacity on it, it'd be a good idea to put a DHCP relay agent on it. This helps more with our fault tolerance around the network and provides us with the ability to dynamically update any of the IP addresses on the network and whenever possible. Now, I would, hang on, go back. That's hot. I would be remiss to. Yeah, that was Virginia Beach like a couple months ago, guys. I would be remiss if I didn't mention on the RAS, radius and IAS installations and the possibility of putting those in based on the number of routers. This would give us central control. The IAS and radius will give you central control over the routers. Right now, the way it would sit is that if you had changes that had to be made, you would have to change it on each individual router. If you had an IAS server along with radius, then you can make those changes from one location and affect all of the routers and affect all and pass down policies to all the users. Then we have high.
Someone get a space bar.
Thank you.
I got questions.
Please hit the space bar.
Go away.
Just to let you guys
Come on
know,
up, guys. Questions?
The way this was set up was they designed out,
I gave them with the project, they designed it out, how they would implement it, what components they need, plan that out. They used the test environment as a way to run whatever services to see what that service does. So we didn't have all the equipment, all the time in the world to run every single possible thing in there. So pretty much things that they may be wondering, okay, how does DNS do this? They ran it in the test environment as a way, and then say, okay, this is how we're implementing in there. That's what the pilot environment was for. If we had 25 machines, it'd be a different story. We don't have that. We don't have time to go and start setting all those machines, make sure everything's set up. So you guys will be doing the same thing. So what you implement or what you plan, what you design is going to be by far much larger than what you're going to have in way of your actual implementation or your test environment itself. Hold on for my question. Go ahead, Peter. I'll let you go first. I'll make you sweat a little bit longer.
I heard you mention that you were going to use Active Directory integrated DNS. Was there a reason that you chose that over some of your other options?
Let's see here.
Was there
some benefit? You guys know the answer to that question.
Yes, there was.
Yes, absolutely.
that would be better.
Within Active Directory, it would automatically share all its information with the other servers and provide additional security inside Active Directory.
Gives us a single point of administration for the network.
Did you have any problems? You mentioned that you built a trust between your two forests, and I wasn't sure exactly what kind of trust it was that you built. I heard mention of two-way transitive and some other terms were thrown out. What was it that you actually designed in the end?
We had to make the original forest with the AFP US domain, and then from there we had to create another domain, which was MAS that we work with, and we had to tell it to be part of that forest, of AFP's forest, but it's its own separate tree so that it can still keep its own presence without having to be mass.afpus.inc. It can just be mass. Whatever we had on the tag.
Did you have any problems getting that trust set up?
Well, to begin with, we put in two domains, and we did have problems with that, so we had to remove one and put another one in and tell it the right way to do it.